Hi everyone. We're here to teach you some Swift basics using Apple's live coding platform. I knew somebody would come in. Hello, welcome. Please.
Hello.
Oh, wait a second. It's okay. We forgive all of you. So we're here to teach you some Swift basics using Apple's live coding environment playgrounds. This is Tim. Tim is now waving at you. I'm Paris. This is Mars. Please feel free to tweet at us. We love to be tweeted at during presentations. Because there's 3 of us, it means we can respond. So we love to do that, keep us on our toes. We all write books together on Swift programming. I think collectively we're up to more than 20 books, mostly for O'Reilly, but for some other publishers as well. And we write a lot of books on Swift programming, game development, and all topics in between. So we like to think we know what we're talking about when it comes to Swift. Mars is writing a book on AI with us, and she also won one of Apple's scholarships for her awesome work on playgrounds. So she'll be driving all the demos today with us.
Mars is our code gremlin.
She is our code gremlin.
On a playground, not on playgrounds.
That's true. So to start off, Mars is going to give you a quick tour of playgrounds, and then we're going to dive into talking about how Swift works.
Okay, so my first demo actually begins on this, which we have uploaded to our GitHub at github.com/thesecretlab/learningswift@OSCON 2018. Because we were writing content for this, we got really excited, and there were lots and lots of things we wanted to include. And we thought, we don't have enough time for all these things, so we did the extended version of all the content we'll be doing here. So if you don't want to follow along or you missed some stuff, we have everything we'll be talking about today and more available for download here. But this is also a really great way to introduce you to some of the things that you can do in Playgrounds visually, which is that it has full Markdown support and is a live code executing environment. This is really invaluable as a learning and teaching tool because it means you can have your explanations and your demonstrations in one place. You can embed images, links. On iOS, they also support a live view, so you can implement like full games and simulations within a playground. And I find it invaluable even in my daily life, just for learning new libraries or testing code. But today, we're going to start out in a fresh one and do this all from scratch. I know not many people will be following along because we don't have tables and this is a live coding thing. It's going to go a bit fast. But I have begun by just importing the foundation library, which is basically like the Swift
Standard library equivalent.
Standard library. You need it for a surprising amount of math stuff, you would assume. You don't have to. And I've also written a function here because otherwise the way that you get a random number, which we often use for demonstrating different functions, is ugly. So this is what we've begun with, otherwise it's empty.
But don't feel like you have to follow along. Like there's always one guy who's like really keen and just like types and goes like a crazy person, but you don't need to follow along to get all of this. We'll give you all the playgrounds.
I'm just going to demonstrate a couple of things that are really, really helpful in Playgrounds when you're first starting out with things, and that it has live results. As you can probably see here, it's lagged from the last thing I typed in. But this is a live environment. I've got it to auto run down here. You can set it to only run when you tell it to, but it will give you line-by-line results. Not only if you store them to a variable, as you see here, it will just give you output. It also gives you loop counters. So for I in 0,
We'll go through some of the Swift syntax shortly. We're just going to show you what Playgrounds can do first.
Up to 10. And now if this runs...
Because it's live coding, we're 100% certain the Playground's going to crash at some stage. So.
It does do that. This is also really helpful when you get to loops, because not only does it do line-by-line results, but you can also put in results that tell you what it was the last time it ran, a history of every time it ran, or a graph of how it's been doing.
Can you actually zoom that in just a little bit, Mars?
Yeah.
Control.
So there are ways you can make it give you grid lines and stuff.
Yep. There's a whole bunch of options for configuring this sort of stuff in your Playgrounds.
And it also has standard console output. Yeah. Cool. So those are the different kinds of output we'll be using today.
Okay, so let's get cracking. So at its core, Swift is a multi-paradigm programming language, which means it's like all the programming languages you know and love, but likes to claim it's better than them. For getting started, let's look at the basics. Let's look at types. So to declare, or types and variables rather, to declare a new variable, you use the var keyword, you give it a name, you then give it a type, and you give it a value. So for example, here Mars has created a new integer of value 1. Because it was declared as variable, it is able to be changed. The other way you can declare your variables are as constants using the let keyword. This pretty much works like exactly how you think, depending on your programming language experience. It's like the const keyword, you can't change it.
And Swift will throw an error if you try and change it.
And this is determined at compile time. So, one of the really cool things about Swift is it actually has full Unicode support. I'm going to say full because nothing has proper Unicode support, which means your strings can very happily have emoji in them. So Mars is just going to quickly throw in a dinosaur there. The other really nice thing though is because it's full Unicode support, you can also use your emoji as your variable names, which...
Look, as far as we can tell, the only legitimate use of this is teaching children to program.
Yeah, and to make it hard to accidentally type in a variable or function name that's dangerous. But it's a nice thing to show off. So Swift as a language is very statically typed. It's one of the more statically typed languages out there, you'll find. Which means if you want to sort of interact with different types, it's going to throw up a lot of errors very quickly once you start running them. So even things like integers and doubles can't necessarily be talk to each other until one's typecast as the other. So yeah, in this case, we're going to get Mars. She's going to create basically a variable and typecast it straight to a double for us.
If I spell it correctly.
If we spell correctly. It's live coding. You're meant to make mistakes. That's the whole fun.
Bless you.
Now, something we didn't point out before, but you may have noticed, you can also declare a variable and let it determine the type, which you don't have to do that. It's just a nice shorthand thing there. But yeah, there's multiple, because it's a programming language, there's multiple ways of typecasting stuff. Just pick whichever one you prefer. Swift also has full support for collections. Out of the box, it has arrays, dictionaries, sets. There's a couple more as well that I can't remember off the top of my head. It has a whole bunch of sort of standard collection types that you know and love. So Mars here is just quickly typing up a lovely new array here. And it works pretty much exactly like how you would expect an array to work. You can add elements to it, you can remove elements from it, you can insert, you can get the size of the array.
There's lots of nice literals and shortcuts for you to manipulate the array. You can add things to it, append, insert, without having to do too much poking around in the structure of the array, like some older languages require of you. You can also count it and remove specific entities from it and specifically assign certain entries in the array and so on and so on and so on. It's pretty powerful and it's pretty simple. And like almost pretty much every language that's sort of come since C, you can also use the subscript sort of style direct element access of an array. Worth pointing out, if you try and access an element that doesn't exist in an array in Swift, it actually throws an exception and crashes your program, so make sure you're not just, Swift throws hard errors for a lot of things that you might not necessarily expect it to. It's because it's trying to be safe and enforce a certain way of coding. Like the company that kind of originated Swift, Apple, Swift is an opinionated language that has a kind of a way it wants you to do things.
Wait, Apple's opinionated? I would never have guessed. Swift, because it's a programming language, has all the sort of maths and logical operators you've come to know and love. We're not really going to show these off too much. I mean, if your programming language doesn't have maths, it's not really going to be useful. It's a programming language. You can define your own custom operators if you want. We're not really going to have time to go through that, but you can define them.
You can use emoji for those operators if you really want to as well.
Please don't. So it, of course, has flow control, because again, it's a programming language. It has all the sort of bits and pieces that you know and love. Something that, like, coming from, so before Swift, I was doing a lot of Java, C#, and Objective-C. Something that I really love from Swift is you don't actually need the parentheses in if statements. I don't know if that's a big thing to anyone else. When I first did that, I was like, but you do, however, need the braces for the if statements. You can't do if and then just tab in and do that. That's not allowed. Yeah, so again, it's an opinionated language. It has its very sort of specific.
Flow control works much the way you'd expect it to work after seeing Swift syntax. Hopefully there's no surprises here.
We're not sort of talking about anything mind-blowing at this stage, yeah. I hope. Apart from the emoji characters, that's always great. So again, it much like it has conditionals, it also has looping. Swift has two main types of loops. It has a while loop, which is your while loop that you know and love. It will continue to run until the conditional that it's got evaluates to true.
Everyone does love while loops, right? Yeah, good.
Cool, excellent. Good. Yeah, I saw 3 heads nod. That's an important number of heads.
What did I call it? Random number.
You call it whatever you like.
You can call it whatever you want.
They can't see your cheat sheet. They don't know what it says.
No, I mean, I wrote a function at the beginning to avoid the ugly random number.
And that'll run who knows how many times, assuming it runs. Come on, Playground, don't crash. Oh no.
Sometimes the entire subsystem that runs the playgrounds just dies.
Playgrounds are really amazing, but they're still sort of like, Apple says they're not beta software, but they're kind of pretty much beta software. In a little while, there'll be amazing tools for just giving to people. I wouldn't be surprised if in a few years you start seeing more and more documentation for Swift, just downloading a playground, and it'll have a live environment that also has the explanations for it.
While we wait for Xcode to recover, if anyone wants to run playgrounds on their iPad and has an iPad, the iPad version of playgrounds is much more rock solid than the macOS one for some reason.
And has more features.
And has more features.
It runs much faster?
It runs faster as well because Swift is running on Apple's own silicon on that platform, so it's all quite mysterious. But yes.
So the other type of loop that Swift has is the for loop, which in some other languages is called the for in or for each loop. It's designed to iterate over a sequence of some sort, so an array or a range of numbers. Yep. Swift does not have the for loop that you might know and love, the for I equals 0, I less than 10, I plus plus. Swift doesn't even have the plus plus operator.
It did for a little while, but they took it out after Swift 1 because they thought it was unnecessary.
Yeah. You can put it back in yourself if you want, because, hey, you can create your own custom operators.
It also doesn't have the power operator, which is really bizarre.
It does not
like
have
as far as the one
Yeah, that is weird. I don't know why it doesn't have
exponential,
that
you have
one.
to take from the foundation library one of the things which you wouldn't think you would have to import for. You have to do that.
Swift does also have proper error handling. If we have errors, we're just going to have the thing crash. But it does have a error handling model pretty similar to most languages, in that you will try some dangerous code and then catch errors that happen and then handle them. Pretty much sort of standard style. Now, one of the unusual things for Swift, depending on what your background is optionals. So it's kind of a side effect of its focus on memory safety. Swift takes the approach that things should always have a value. Now, we all know as programmers there's going to be plenty of times when you can't guarantee something will have a value and has to be set to null. In Swift, null is called nil for various reasons. So you can't set a variable to nothing, or nil in this case. So Swift, to deal with this, comes up with this concept of optionals. And optionals are types of variables which can store a value of their type. So in this case, we've created an optional int. But they can also store nothing, or nil, as it's called in Swift. Now, this has some interesting side effects. Because this is potentially dangerous, you have to handle this. So you can't just directly use a optional value like you could a normal value. And there's a whole bunch of ways of doing it. The first way is with the forced optional unwrapper, I believe is the name of the operator, which is basically that exclamation mark there at the end. What we're going to the compiler is unwrap the value. I don't care if there's no value. If there is no value in there, the compiler will actually crash the program when it hits, it's not the compiler, the program will crash when it hits that point. Memory safety. The next way is to use the optional unwrap operator there, which is that question mark. I wish they didn't use a question mark because question mark is so overloaded, but whatever. What that does is it tries to unwrap. If it fails, it just sort of like silently fails and continues with the next chunk, which can be really, really bad. Cool, yep. The third way is to check if something is optional and then, you know, worry about it. These are all sort of like getting a little bit weird as we go along. So in this case, this is what we're doing is we're using a structure called if-let, which basically means if there is a value inside optional integer, unwrap it, give me the non-optional form of it, which is 9 times out of 10 what you're probably going to want. The final way is what Mars is right now, which is called guard-let. I should say you could also do guard-var if you want to be able to mutate it, or if-var, which works pretty much the same, except this happens at the scope of the program. So in this case, what this is doing is it's going to create a new variable called integer, which will have the value of optional integer. Otherwise, it'll run the else block. In this case, we've just put a fatal error in there, so the program will actually crash, which is what all good programmers do. But it means from that point onwards, integer has the value that was inside that optional. Now, the thing about the guard-let, guard-var syntax is that you have to ensure that the scope exits if the else block is triggered. So you'll either have to return or throw an error or fatal error. Please don't fatal error. But yeah.
All these pieces of Swift are basically in there to make sure that if you make an error, the whole thing dies, or you don't make an error at all. It's trying to make the code you write safe by default, which is one of the design goals of Swift.
It is a little weird when you first get started because you're probably quite used to being able to set null wherever and whenever you want. In Swift, they want you to think about it the other way. They want you to think about it as null is the unusual case. You deal with it when it runs up. Otherwise, you make sure everything is nice, clean, memory safe. So on to functions now. Again, it's a programming language, so it has functions. If it didn't have functions, it would be terrible. So functions are pretty much declared just using the func keyword, which I assume it stands for function. I've never actually looked it up. Actually, I only recently learned what integer means. It's from Latin that means like whole or complete. Yeah, there you go. Useless trivia for you from Tim. So this is a function here. It's pretty much a standard sort of structure. The very interesting thing about Swift functions is what happens with their labels. So Mars, if you could write up a new function that has some labels, please.
It's not going to run, so it's not going to demonstrate very well.
It's not running? Oh, you useless playground.
Generally, if you run more than one playground a day and you don't say the right incantations.
Again, they work so well on the iPad. I don't know why they put, I know why they put so much effort in the iPad. It makes them more money. But so, actually, is that readable up the back?
Currency.
Yep, cool, yeah. Just realized we should probably double check that. So we've got a function here called make shouting from input. Is that correct, Mars? Is that exactly what you've written?
Yes.
Yes.
And it doesn't really matter what we're doing here in the code. Specifically, we're just going to uppercase the whole string. So it's like, which, as we all know, is the most important thing you can do to a string. And it returns a string. That's how you show return syntax. You have a little arrow at the end and then the type that it returns. As opposed to putting the return type at the front, it's just a stylistic thing. The idea is you read it left to right. The very interesting thing about Swift and functions is the parameter labels in there. So this is called make shouting from input returns a string. That's the idea how you meant to say it. You meant to sort of read it as if it's a sentence. Apple have always had this dream of
human readable program.
Human readable program, and it's never going to happen. But like they keep dreaming, and good on them because most of the time it does actually help to some degree. The interesting thing about this is it means you can't ignore the labels. They have to be in there. Though these are non-optional labels, and you can't rearrange them. So in some programming languages, from memory, Python lets you reorder the labels inside a function call. In Swift, you can't do that. Their order is fixed. So that is basic functions. Now, Swift also comes with a whole bunch of higher order functions. So it's a nice, fancy, modern language, which means it has all the, what's it doing there?
It yelled at me because I put an equal sign in.
It has a whole bunch of these sort of higher order functions that you know and love. So it has map, reduce, filter, those sort of ones that you've come to expect.
You have to make an array.
We have to make an array first. We'll need some data. You always need data. That's the problem. Where do you get the data from? It's all about the data. So if you don't know about map, reduce, filter, which are three of the more common sort of higher order functions you'll see out there, filter will filter is applied to a sequence. In this case, we're going to apply it to an array. It will filter the elements based on a predicate that you give it. So, you know, you could go, does it have the letter A in it if it's an array of strings, or you could pick what you want. In this case, we're checking if it has the prefix of this. So in this case, we'll keep everything but the last element.
Case sensitive. Loses the first one too.
It is case sensitive from memory, yeah.
Yeah.
Yes, in this case, there is a case insensitive one. Interesting enough, because Swift has full Unicode support, it treats certain characters in ways you may not expect. So if you have like an O with an umlaut, it will treat that the same as if you type an O and then the umlaut character. It will actually make those equate to each other. But it's a total mess in your head if you're trying to think about how to program it. But it does handle that for you, which is lovely. So filter, you know, limits based on the predicate. In this case, the predicate is, do we have this? Next, we're going to do map. What map does is it goes through all the elements in the sequence and then applies a function to them, returning a new sequence of that applied function. So in this case, what we're doing is we're going through all of them and we're making them uppercase. So we're just returning a string. You don't have to return a string. You could return an int, for example, which could be the count of all the elements in each string. And then the final sort of higher order function that you'll often see is reduce, which reduces the array down to a single value using some method that you provide. So in this case, what we're doing is we're going to count all the letters. We're going to count the total length of our string as our array as if it was one giant string. So we're getting the count of each string, adding it to the previous value, and then continuing.
It's worth noting that the reason that this argument.count syntax works is because under the hood, strings are effectively treated as collections of characters and have all of the same element abilities
Sort of,
as
yeah.
arrays.
Yep.
So you can go string character index or dot count or dot whatever on a single string as if it were an array of strings or characters, which is great.
But you shouldn't, or more importantly, you can't directly access it as if it was an array. So you can't go like my string element 1 and try and get the second character. That won't. You can do it, but you shouldn't because it's going to do weird things. Just pro tip, speaking from someone who tried to do that, coming from their old school thing. They're like, why is this not working? Oh, it's because it's an umlaut, not a character that I expected. So everything we've actually been showing off so far with functions are technically closures and a special form of closures which we've called functions. Now, closures and functions in general in Swift are actually full, what do they call them, first-class types. That is, they are as important and regarded in the same respect as, say, an int or a string or a double. And function calls are actually just some syntactic wrapper around a closure. So a closure is pretty similar to a lambda from many other languages. It's basically a function you can create and call dynamically and store into variables.
Or a block if you ever used Objective-C.
Or a block if you ever used it. Did anyone use Objective-C?
Yeah.
Yeah. Don't you miss the square brackets just a little bit?
So the same person who was responsible for adding blocks to Objective-C is responsible for Swift.
So what we're doing here is we're basically creating a random number generator here that will return a Boolean. Will return a random Boolean based on some sort of closure that is going to be passed in. The really nice thing about closures is that you can use them to build up functional programming paradigms, because Swift takes that whole multi-paradigm programming language thing, which every programming language seems to really be pushing hard now, which means even though currently pretty much everything we've done has been your traditional imperative declarative programming, you can actually do Swift fully functionally. I'm going to sort of caveat that in that a lot of the libraries don't support that,
really
but in theory you can.
It's not really a functional programming language so much as a programming language that has been inspired by how functional programming languages do things.
Yeah, but there's nothing stopping you writing everything using closures, capturing values correctly, passing them through in closures. It's pretty much entirely up to you. So this here is a, which one have you done there, Mars? We have way more info, so I need to double check. Cool.
Get random bool.
Yeah, so this is one that will basically return a random bool based on the value of a number. And you can call these wherever you want. They're storable in variables. And another common pattern you'll see in Swift is they will take in as their last parameter in a function a closure, and that will be run when the function completes. So instead of having a return value, you'll instead pass in a parameter, you'll instead pass in a closure that you'll run on completion. How are we doing for time? Cool. Yep.
We might just quit and relaunch Xcode to make
Because
the
it
playground
appears to
actually
have fully
compile.
broken.
So
In the time-honored tradition of a live
make sure
coding
it's
demo,
saved. Yep.
things appear to have broken. We can enjoy Mars's wallpaper. That's
pretty-
Westeros in
it's
Minecraft,
castles.
if you're curious.
It's this one.
So it actually compiles so we can prove that this is running rather than we just
We're
typing.
not just gibbering.
So it's more live typing
I'm
than
just
live
kidding.
coding then.
Yes.
You can trust us, right? We're trustworthy.
You got that from your own GitHub. Dangerous. Okay.
Okay, well, let's
come
hit the
on,
play
you can
button
do it,
and see what
Xcode.
happens.
So something that's really nice about playgrounds that we're not going to have time to show off today is you can actually break your playgrounds up into multiple pages, is the terminology they use, and you can effectively distribute like a playground book where each page is a new section. You can access the bits that you've written in other pages. You can have shared resources. It's actually a really cool thing that I think at the moment is not being used much because Apple still isn't quite sure how it should be used yet, but I wouldn't be surprised if in a few years we start seeing it sort of come together in a really interesting learning way. It's sort of like a more extreme approach of what Jupyter's trying to do. Jupyter Notebooks are trying to make knowledge accessible in a straightforward way. I think Apple's trying to make education, what's the right word? Accessible in a specific kind of way. So Jupyter's trying for the global, Apple's trying for the specific. But I think at the heart, they both sort of have the same sort of goal of live environment with the information and supporting knowledge you'll need to make use of it.
So now we're back up and running. We're
excellent.
I probably have a way too long example of closures, but it's much better.
There's not really many great ways to show off closures that aren't, look, we've stored a variable inside it, we've stored a function inside a variable and then ran it. So what we're writing here is, we're writing something that will assess the how good of a shuffler a random number generator is in this case, or rather how good a shuffling algorithm is, which we think is a more interesting example than most functional ones where they create a thing that adds, because while that's cool and all, we all know how to add. We all know how to add, right? Yeah,
I think so. This is a great example of closures because it shows how you don't really have to care about how something's implemented after you've done it like this, and you can just tell it to do the thing, and it does it based on whatever closure you give it. So it's a little bit of typing, unfortunately, to get somewhere interesting. So we can all stare at Mars for a second while she types.
Yeah.
And then we'll hopefully get
while
there.
While Clowny Scotsy plays.
That's true.
Oh, I did that thing, rookie move, drinking conference coffee before you have to type live for an hour.
Does anyone actually like conference coffee? I drink a lot of it.
I do,
But
generally.
Okay, Mars likes it. Oh, of course, Cassie
They gave me a
likes it.
mug to put it in. It's the way to my heart.
Do you want to just copy it from the, and here's one I prepared earlier.
No, we're
I
nearly
didn't
there.
know.
Look, she's almost there. She's got one more function to make, I think.
Yes.
Yeah.
It's a good
So
one.
we're making a function to shuffle it with now. Which,
Because you need something to pass.
yes.
So what we've done is we have a function which will assess how good something is shuffled, which will take in a function that does the shuffling. And technically they're all closures because they're functions, and all functions are closures under the hood. But in this case, the specific closure that we're going to be passing in will be the shuffler itself, the shuffler, yeah. The dealer, I guess, is probably a better word than shuffler. Should have called it dealer.
The dealer, yeah.
Hindsight's perfect. It's not. Hindsight's terrible.
It's worth noting that this line is important because anything you pass in as a parameter is then immutable. That's the reason for line 180.
But if you do Swift, most of the time you'll be using closures, unless you're really big into functional programming, will be as completion handlers. Most of the standard libraries, especially those involving URL handling, will take in a completion handler for, yes, I have finished downloading the file you've asked, here is the file, and then you run a completion, you give it a completion handler to run once it has done that, which is generally a better way than, most of the time it's a better way than trying to handle it any other way, perhaps like waiting or blocking until you get there. Generally, I'm being abstract there.
So we're almost there. We're pretty much ready to go, in fact. Okay, now we're actually ready to go.
No.
Almost.
Needs braces.
Needs braces.
There we
We
go.
forgot the
Because no one
braces.
ever uses this syntax.
It's true.
So this will tell us how well shuffled
If the playground is still
it
running,
shuffles. Of course it's still
Oh.
running. Oh.
you've used array a few times, maybe.
Oh, we called it array before.
If statement braces.
If statement braces.
There we go. Oh, we're nearly there.
Thank you.
Good catch.
See, you need them braces. They're important, or else you
Yes.
make mistakes.
The
Have the compiler mock you.
Nope.
I actually like compilers mocking me. I
They're
actually think that's a
somewhere
better thing than having the program mock
right
me
there.
later. Maybe that's just me.
String and character. What did I do?
You got there? Mars, just copy here's one we did earlier example.
Yeah, we can probably just show them it's having issues there.
Classic Swift. It looks the same.
It looks the same, yeah.
I think that's called classic programming.
So something weird is going on. We'll fix it at the end, and I think we should just move on to structs.
Should you just comment that out, Mars, so we can continue?
Yes. Okay.
So Swift, everything we've been showing so far have all been reference types. Swift actually has a few different meta types, I guess. So the first one of those, and pretty much everything we've been looking at so far have been structs. You can declare a new struct using this marvelous syntax right here called struct, and then the name of what you want the struct to be called. So in this case, we're making a new struct called talk, which will have a name and a boolean inside of it. And then we can start instantiating and using these structs straight away. Pretty much everything we've shown, no, literally everything we've shown so far has been a struct.
I really love the way structs work in Swift.
So strings are structs, arrays are structs, dictionaries are structs, ints are structs. Pretty much all of the base types in the programming language are structs, with a couple of exceptions. Now, structs work pretty much like you expect. They have properties which you can access the values of, and they can have functions which you can call upon them. Pretty much like what you would expect in any programming language. However, because Swift is what we like to call a multi-paradigm language, it's also object-oriented, which means you can have classes as well for building up that lovely object-oriented syntax that we know and love. And that's because even though structs at least initially look pretty similar to objects, they can't actually be inherited. You can't have an inheritance tree for your structs, which, depending on what you're doing, heavily limits your functionality. But it does depend, again, on what you're doing. So instead, we can have a class.
Classes and structs look very similar in Swift.
Which is by design.
Yes.
So in this case, we've got a new person, which has a name, and we're going to need an initializer. So the first thing that's different about a struct and a class is that for free, you get a member-wise initializer for a struct. So you don't have to write an init method. For a class, you have to write an init method. Various reasons why that's the case. But the advantage of a class is that it's an object, which means it can be inherited. Yep, Kasky? Well, it doesn't have a default value. You have to tell it what values it has. Yeah. You get a free initializer, you still have to call it. It doesn't have values by default. Yep. Yeah. Unless they're optional, in which case they default to nil. But, yeah.
This will throw an error. Missing argument.
We can fix some of the code.
Yeah, missing argument. Yeah. But classes can be extended, unlike structs. So you can then create a new class from an existing class.
Which we will do now.
And the syntax for that's pretty straightforward.
It's pretty much what you'd expect.
So we're just going to create a speaker, which is a subclass of person, and it's basically just a person that has some talks. Pretty straightforward. Now, Swift doesn't really care about sort of anything, is probably the best way of saying it. So you can have, except for type safety, that's the one thing Swift cares about. So you can have as many initializers as you want, just provided at the end of the initialize method, every non-optional property has to have a value. That's pretty much the only rule when it comes to creating your classes. Swift does not have multiple inheritance. You can only inherit from one superclass at a time for what I consider as good reasons, because it just avoids so many problems. But with that said, Swift is not actually a big object-oriented language. Swift does not hugely take the approach that you should be creating massive class hierarchies. It generally takes the idea that you should be extending existing classes and giving them the necessary functionality, as opposed to trying to subclass classes as you're going down. Yep, Paul?
Does Swift have interfaces, roles, and
Yes.
Yes.
Yep. Which is almost next.
We'll come to that next. Probably
Almost
almost last,
yeah.
in fact, yeah.
So the whole idea of Swift, where are we up to there? People, just make one person, I reckon, Mars. Just make one person.
We have 5 minutes left, so we're going to try and cover as much as we can in our 5 minutes.
So I don't think we'll demo this, but it's worth pointing out the biggest difference between classes and structs is that classes are reference types, structs are value types.
Yeah.
So if you duplicate a class, well, if you assign a value to an existing class, they point to the same object. If you do that with a struct, they copy it.
Kind of makes a lot of sense in your head too.
The last thing I kind of want to talk about, because as Paul asked, is do they have mix-ins or interface, whatever. In Swift, they're called protocols, and we're not going to have enough time to show off everything really cool about them, but Apple's own approach is that Swift is actually a protocol-oriented language more than it is an object-oriented language. They want you to build things up out of these protocols instead of trying to build them up out of inheritance or any other way.
If you want to be a really good Swift programmer, get your head around protocols, because this is how Apple composes their own software with Swift, and this is how Swift is designed for you to compose the software.
Well, most of their
Most
software.
of it.
Apple's
It's how
a big
Apple claims
company.
they compose
Yeah,
their own
this is how
software.
Apple claims they compose their stuff. So Mars has described a new protocol here, created a new protocol called describable. All it does is it has a function called describe that returns a string. And now what we're doing is we're just extending ints. You can pretty much extend everything in Swift unless it's declared that it's locked down. It's pretty rare though. All of the base classes are extensible, so go nuts. Mix things up, make them crazy, weird stuff. So now we should just be able to go like 5.describe, he says.
And your if Xcode hadn't crashed 10 minutes ago, you would see something happen.
Yep.
Yes.
Yeah.
We extend arrays in all sorts of ways you should not do.
Yeah.
Yeah, he can do all sorts of stuff.
You can also give custom subscripts to everything, which is
Yeah, no,
awesome.
it's right for Terra, but like all things in computing, it is great power, and as such, it has great responsibility and Spider-Man quotes.
Yeah.
Paul.
Protocols provide function body keys for default.
Do protocols provide function bodies to be used as a default? No, they just require it to exist, but you can actually add default implementations to a protocol by extending the protocol itself and then implementing that in the extension. Swift is mad about extensions. The really nice thing about this is you can also add, what's the right word? You can add, I've forgotten the terminology. You can put constraints upon the extensions that you're implementing. So if you know, for example, that this is going to be used a lot with arrays of strings, you can implement the default version going where it's an array of strings and then implement that yourself and not have to worry about it, but then still allow other implementations of it to take over from that default implementation. Pure, yes. It's not actually duck typing, but yes, yeah.
Close enough. So we've got like 2 minutes left. In that time, Mars will probably keep typing a few things just so you can see what we're doing, and we'll kind of sum up for you. Swift is a very, very powerful, very, very modern language that emphasizes safety amongst all other things, really. If you want to do OO in Swift, look into protocols, because that's kind of how Swift does it. It's the Swift-flavored version of OO.
Yeah.
If you want to use Swift and are not on a Mac, Swift is very, very healthy, robust, and solid on Linux. There is no playgrounds on Linux, but there is a REPL, which functions pretty much the same way. It's stable and great and wonderful. Apple provides, well, the Swift open source project, which is effectively largely Apple, provides binaries for popular Linux distributions and installs and compiling instructions for others. There is very early Windows support. Apple doesn't seem to care about Windows support, and the community also doesn't seem to care about Windows support. But theoretically, if the community cared, that would happen. There's no barriers to that happening. But Linux support is very robust, and there's a bunch of really great web frameworks, mostly coming out of IBM's collaboration with Apple.
Thanks, IBM.
Around that. So you can use Swift to build pretty robust web apps these days, and Linux apps. And of course, you can build native macOS apps, iOS apps, and play with the playgrounds. And if you have a kid and they want to learn programming, iPads in a playground are a really great, not actually lock-in way, despite using an iPad to teach them programming. It's pretty cool. We strongly recommend checking it out. And with that, we've got like 40 seconds left. Thank you for coming to our talk. If you want to read more about Swift, Apple's docs are amazing. There's free books on Swift. Also, with the complimentary Safari membership you get from being at the conference, we've got a book called Learning Swift, which you can read for free as part of that. Check that out. Again, thank you for coming. Please come and talk to us if you have any questions.
We're here all rest of the conference.
So if you check out github.com/thesecretlab/learning Swift at OSCON 2018, which is linked from the page, or will be linked from the page on the OSCON website, you can get all the code with notes and annotations to follow along at home of what Mars has been typing here for you. So
in a version we tested.
it's really good. It's actually an awesome Swift tutorial, so check it out.